In this video, we're going to look at some linear equations that have special solutions. Normally when you solve a linear equation, you get an answer that looks something like this, like x equals 6 or x equals -1, which means that that numerical answer that you got is the only number that can be plugged back into your equation to make the equation true. Well, every now and then you're going to run across some linear equations that do not have one single solution like that. So those are the ones we're going to look at now. So for number 1, we have 4x plus 7 equals 2 times the quantity 9 plus 2x. And we know when we see parentheses in an equation, we want to go ahead and get rid of those by distributing the number out front. I'm going to bring down the 4x plus 7. 2 times 9 is 18, and 2 times 2 is 4x. Okay, now when we see that we have variables on both sides of the equation, what we normally want to do is get those variables on the same side of the equation by subtracting one to the other side. So if we take this 4x and subtract it from both sides, it cancels out here, but it also cancels out here. So our x's are completely gone, and we're left with the equation 7 equals 18. Okay, when this happens and your variable has been eliminated, you want to look at what you have left and decide if that's a true statement or not. Is 7 really equal to 18, or is 7 not equal to 18? And 7 is not equal to 18, so that would have been a false statement. So when that occurs, you have no solution to that equation. Sometimes you write no solution like that, which means there is no number that can be plugged into this equation for x that would make both sides equal each other. For number 2, we have 12 minus 3x equals negative quantity x plus 6 minus 2x. So again, we have some parentheses we want to get rid of. So go ahead and distribute that negative. So we'll have 12 minus 3x equals negative x minus 6, and then bring down the minus 2x. Okay, before we start moving things from one side of the equation to another, we do have some like terms on the right side. Negative x and negative 2x need to be combined to make negative 3x. So that side becomes negative 3x minus 6. Okay, and then we want to take one of these 3x's and add it. So when I do that to both sides, again, my x's cancel out on both sides of the equation. So I'm left with 12 equals negative 6. 12 does not equal negative 6. That's another false statement. So this again is a no solution. Okay, for number 3, we have 6 times the quantity x plus 4 equals negative x plus 24 plus 7x. So let's distribute the 6. 6 times x is 6x. 6 times 4 is 24. And then on the right-hand side, we have some like terms, so we can go ahead and do this all in one step. We have a negative x and a positive 7x. So if we combine those, that's like combining a negative 1 and a positive 7. So if we add that, we get 6x plus 24. Okay, again, we want to get our variables on the same side. So I'm going to take this 6x and I'm going to subtract it. Also subtract it from the other side. And again, my variables cancel on both sides. So this time I'm left with 24 on the left. I'm also left with 24 on the right. So this time my statement is 24 equals 24. That is a true statement. So when that statement's true, that means we have an infinite number of solutions. So I'm going to write infinitely many solutions. That means I can plug any number in for x, and my equation would work out to be true. Now, I went a little further in this problem than you actually have to, most of you may be able to tell from this step right here that this problem is going to have infinite number of solutions because you can already see that both sides of the equation are the same. You have a 6x plus 24 on the left. You also had a 6x plus 24 on the right. So if you notice it there, you can go ahead and stop. But if you don't notice it, keep solving the equation like you normally would, and your variables will be eliminated and you'll be left with a true statement. This is also called an identity. Number 4, we have 9 plus 8x minus 2 equals 2 times the quantity 4x plus 1 plus 5. Okay, so I want to go ahead and get rid of these parentheses. I also have some like terms on the left side of the equation. I have a positive 9 and a negative 2 that I can combine to make 7. So I have 7 plus 8x on the left side. On the right side, when I distribute 2, that gives me 8x. And then 2 times 1 is 2, and then plus 5. So let's simplify a little bit. I'm going to bring down the 7 plus 8x. And on the right side, I can combine my 2 and my 5 to make positive 7. So I have 8x plus 7. Hopefully you can see that these two are the exact same thing. 7 plus 8x and 8x plus 7 are the same because when we're adding, the order that we add in does not matter. So you know right now that this is going to be another identity problem where you have infinitely many solutions. But let's go ahead and finish solving. In case you don't notice that, I would subtract 8x to try to move that 8x to the other side. But what happens again is it cancels on each side of the problem. So I'm left with 7 on the left. I'm also left with 7 on the right. That is a true statement. 7 equals 7. So I have infinitely many solutions again.